In his latest book, the well-known author and physicist Dr. Paul Halpern addresses a seminal theme in physics: the origin of the rivalry between the Big Bang theory and the steady-state theory. The theories were emblematized in the 1940s right until the mid-1960s by two extraordinary physicists, the Russian American George Gamow and the British Fred Hoyle. While Gamow became the public face of the Big Bang model of the universe, now the most widely accepted theory of its origin, Hoyle became the counterpart for the steady-state theory. In his critically acclaimed book, Flashes of Creation, George Gamow, Fred Hoyle, and the Great Big Bang Debate, Professor Halpern offers a highly engaging history of how the two great intellects, who also became two pioneering science popularizers, kept the debate alive through their personal fascination with Hollywood, showbiz, and television. The Big Bang versus steady state is one of physics' greatest debates, which was settled in favor of the former after two physicists, Arno Penzias and Robert Wilson, discovered constant radio static from all directions of the universe in 1964. Dr. Halpern spoke to Mayanchaya Reports to explain some profound issues involved in the debate. First, the obvious question. I presume you are a steady-stater.
Well, I'm interested in the steady-state model of the universe for historical reasons, but I believe that evidence shows that the Big Bang theory is more supported.
I see. That brings me to something personal that I want you to resolve if you can. When I first began seriously reading about these subjects, I was 18 years old, so pretty callow at that stage. And about 3-4 years later, I happened to meet Dr. Jayant Narlikar, who had worked with Professor Hoyle. And my understanding from talking to Dr. Narlikar and reading up was that, in a sense, the Big Bang was a sort of a local phenomenon which was part of the overall steady state. So Big Bang didn't really upend or disturb that steady state. That was my understanding at that age. I don't know if this is fanciful, foolish, or there is some substance to it.
Well, Professor Narlikar has continued the work of Hoyle and also Jeff Burbidge, and they worked together on a project called the quasi-steady state cosmology, because the original steady-state cosmology was eventually non-viable. And the reason it was non-viable is because it didn't predict the proper amount of helium in the universe. So when Hoyle did a paper around 1964 calculating the amount of helium in the universe, he said, well, maybe there is something to the Big Bang idea, because helium cannot be produced with such large quantities in stars. So he decided to pursue either the Big Bang or something called little bangs. Little bangs are local explosions. So that's probably what Professor Narlikar was referring to, is that you can create something similar to the Big Bang cosmology, in his view, by having little bangs, which are local events that happen throughout the universe, which produce the helium that we see in the universe through ultra high energy.
Right. So I'm not completely off the mark in my memory, right?
Yes.
All right. No, I'm glad to. This has been long standing in my mind now, almost 4 decades. I'm so glad you helped me throw some light on that. I'm grateful for that.
Yeah, well, Professor Narlikar is a wonderful physicist and also a great writer, and he wrote some popular books on cosmology. And I had the pleasure of interviewing him by email several times, and he was always very responsive to my questions and had wonderful anecdotes.
Oh, I see. He's a remarkable man. Yes. You bring two giants of physics in Fred Hoyle and George Gamow in this book, both incidentally possessors of rather compelling personalities, as you point out. And they met just once in their lives in 1956, as I read it. Uh, since they were the two great battling opponents on two sides of the divide, how hard was it for you to bring them together as a first step in your mind?
Well, I always thought of the battle between Big Bang and steady state as Gamow versus Hoyle. And I
I
looked
see.
into that, and there are certainly other people involved in both theories. For example, the Big Bang theory was originally proposed by a Belgian priest, George Lemaitre.
Right,
And so Lemaitre um, originally came up with the idea of a primeval atom. And that was a notion that the universe began in a very dense state, but not. Lemaitre didn't do very much with that idea aside from say, well, there's an atom that made up all the matter in the universe, and then the universe expanded. And also, Lemaitre was a priest. He was very humble, very shy. So he did not blow his own horn. He did not try to bring attention to his theories. In fact, he was very modest about his theories and didn't really publicize them very much. Well, Gamow was the one who really took charge and publicized the Big Bang and developed his own ideas, which were that all the matter in the universe, according to him, was created in the Big Bang, and all the chemical elements were forged there, which turned out to be partly correct. Helium is forged in the Big Bang, but not the higher elements.
right,
And similarly, Hoyle was not the only person behind steady state. There was also his colleagues Tommy Gold and Herman Bondi
right.
co-developed the idea. But Hoyle was a master at publicity, and he was on BBC Radio, and he wrote many books. So in the public mind, the battle between the two theories was between those two eminent scientists.
Right. Ironically, I think it was Hoyle who coined the term Big Bang. I think you point out in your book, right?
Yes, that was in 1949.
Right,
Hoyle was invited on BBC Radio to talk about cosmology, and he wanted to contrast his theory with opposing theories. And he said, isn't it kind of silly to think about all the matter in the universe exploding billions of years ago in this colossal burst? Doesn't it make more sense to think about the matter trickling in very slowly over time, which was the steady state theory? So he dubbed the exploding universe theory the Big Bang. And that was a term that George Gamow never liked. He said the universe was never very big, or not very big at the time, and there certainly wasn't a real explosion. It was just an expansion of the universe.
I want to go back a bit to Lemaitre. You mentioned him being a priest. Uh, is that? Do you suspect that there was some measure of Christian influence in his thinking, in the fact that he said it just came into being like that?
Well, one can hypothesize. He certainly was a religious person, and he certainly was trained on Christian thought. Of course, Christianity, along with some other religions, believes in a unique beginning, whereas other world religions, Buddhism, Hinduism, and so forth, talk about cycles and not a clear beginning. So that could have been a philosophical influence. But that said, Lemaitre was very careful not to combine the science with the religion. He was careful to say, this is my scientific ideas. Let's look for scientific proof. And religion is something altogether different. And in fact, he told the Pope, do not conflate the two. And the Pope Pius, pretty much ignored him and continued to connect the Big Bang Theory with the biblical idea of Genesis, and gave some talks on that idea.
Right. So that means it would have taken quite a while from it to transition from the realm of theologians to serious science. Would you care to talk a bit about that?
Well, of course, for many thousands of years, theologians were interested in the idea of how everything started. And it was more of a philosophical or religious question. And it was only when Albert Einstein developed his general theory of relativity in 1915. So we're only talking about 106 years ago that science was first able to talk about a dynamic universe. And once you talk about a dynamic universe, you can have a solution of Einstein's relativity in which the universe begins very small and becomes very large. So modern scientific cosmology dates back only 106 years to relativity, which is pretty remarkable because that means that there are people on Earth today who were born before
Right.
scientific cosmology started.
That's true. I want to go back a little bit to my earlier point about. I'm just looking at my list of questions. Steady state. Why do you think it did not strike deeper roots at that point? You have already described about the problem of elements and their emergence, but was there something bigger than that at stake?
So steady state was proposed in 1948, and interestingly, it was proposed after Hoyle, Gold, and Bondi saw a horror film that had a bit of a twist ending to it, where the ending was matched up with the beginning, so it kind of repeated itself again and again, and had the advantage that the universe pretty much stays the same over time. So even though the universe is expanding, while the universe is growing, new galaxies fill in the gaps between the old galaxies. As the old galaxies move away, new matter slowly trickles in. That becomes clumps of matter, eventually large enough to ignite into stars, and those stars form new galaxies. So that's a pretty remarkable idea, but it's very testable because you can negate it by saying if you can if you can find proof that the universe is very old, or if you can find proof that distant galaxies are older than close galaxies, meaning that galaxies age over time, then that points to a real beginning. If
Right.
all the galaxies are randomly scattered, so you have young galaxies, new galaxies everywhere, then that would point to steady state. But as a matter of fact, if you look out further and further, you see galaxies that are more and more active. That means galaxies from the past. And eventually you see quasars, which are galaxies that are so young that their cores are producing this incredible burst of energy, possibly due to supermassive black holes in the center, creating all this activity. And this activity shows us bursts of energy. And because of that, we believe that steady state is ruled out. But at the time that steady state was proposed, the Big Bang Theory had a lot of problems, and one of those problems was the fact that the Big Bang Theory predicted that the universe is 3 billion years
Right.
old, and stars, as we see them, including the sun, are much older than that.
Right. Where does I'm perhaps digressing a bit, where does the idea of multiverse fit within the steady state? Is there any possibility at all?
Well, you could construct a steady state based on the multiverse.
Okay.
For example, you could say, uh, if Hoyle wanted to say this, he could have said that our universe has its own Big Bang, but that's not really the beginning of everything. That really there's a larger cosmos, and that there are many bangs going on in
Right.
other cosmoses. And Hoyle was disinclined to talk about the multiverse, and that's because he's very practical and really liked the idea that everything we talk about should be observable. And that was his maxim: do not start talking about things that cannot be observed. Because if you start doing that, then you go into philosophy rather than science.
Right. The only reason I raise it is because the idea of multiverse appears to have gained some ground in the last decade or so. It's somewhat fashionable too, but that's the reason I thought it might be an interesting vantage point on the steady state and multiverse. Anyway, how do you think Herman Bondi and Thomas Gold would have looked at Fred Hoyle becoming so emblematic of something that they founded together?
Well, I think they were impressed by Hoyle's ability to reach out to the public. Hoyle always gave them credit, and they always gave Hoyle credit. So they actually wrote separate papers because Hoyle came up with the idea of a creation field, explaining how matter comes into place, and they didn't really like the idea of a creation field. They saw problems with that. and they favored more of a philosophical description of the universe called the perfect cosmological principle, saying that because space is uniform, time must be uniform also. And Hoyle, I think, found that a little bit too abstract. So they produced separate papers, and Golden Bondi's paper came out first, actually. Hoyle's came out second, but they both came up with the idea at the same time. And that was more of a problem for Hoyle because occasionally people thought that it was Bondi and Gould's idea and that Hoyle was just a popularizer. In
I see.
fact, the British astronomer Royal once wrote to Hoyle and said something like, were you the one who made the idea popular? And Bondi and Gould were the ones who invented it. He said, no, 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 we all came up with the idea at once.
Right, right. In your book, you talk about this common attribute between Gamow and Hoyle as having great fascination for the showbiz, Hollywood, television, etc. And that explains both the fact that they had that personality and they both went on to become perhaps the pioneering popularizers of science. You have the current descendants, someone like Neil deGrasse Tyson, etc., even Carl Sagan earlier. Would you like to talk a bit about what drew them to popularizing science at that point?
Well, both Gamow and Hoyle grew up in the age of the movies, and they were really among the first generation uh, to grow up with cinema. Gamow, of course, was a bit older. He was born 11 years before Hoyle, and so the films he grew up with were some of them were silent films.
Right.
And but Hoyle's mother worked in a cinema. She was the woman who played piano during silent movies to accompany the action of the film, and she would perform classical pieces. And as it turned out, people would come to the cinema because they really liked her piano playing, not for the films. So so Hoyle would sit sometimes in the cinema, watch the movies, and be impressed by the plots. So he always enjoyed thrillers, mystery movies, and then he went on to develop his own television series, A for Andromeda, which was a science fiction action series. So he had a real sense of the cinematic. And the same with Gamow, although Gamow's favorite kind of film was westerns, cowboy movies. And when Gamow worked with Niels Bohr at the Institute for Advanced, the Niels Bohr
Right.
Institute, Institute for Theoretical Physics in Copenhagen, um, Gamow would watch films. They would show films there for recreation. And then at one point, he and Bohr got into a little bit of an argument because they wanted to decide uh, why in cowboy films the hero always wins and the villain always loses during gun battles. And Gamow said, "Well, if the villain is evil, the villain's going to draw his gun first, his pistol first, and therefore defeat the hero." And Bohr said, "No, no, no. The hero is always going to win." So they tried it out with toy pistols in Copenhagen, and it turns out Bohr was correct that he was first.
I see. I see. You also talk about the different kinds of sense of humor that they had. Hoyle was the more Brit wit, as I call it, and Gamow was more rambunctious, sort of loud Russian humor in a sense. Would you like to tell a bit about that to our readers and listeners?
Yeah, so Gamow always liked puns and pranks, and he would play a prank on a number of people, where he loved to push the foreign editions of his books, and so in some foreign languages, uh, instead of going left to right, the wording is right to left, and the book starts in a different direction. And
Right.
sometimes he would hand somebody a book and say, "I've signed this book for you," and someone would open it as if it's an English language book, they would open it on the wrong side. And then Gamow would write, "Ha ha, you opened the wrong direction. Don't you know anything about this language?"
Right.
And then they turn it over and he'd really autograph it in the other direction.
I
So that
see.
was one of the pranks he played on a few people, including James Watson, the famous
Right.
geneticist.
Right.
And then he also loved puns, including one of his key papers was the Alpha, Beta, Gamma paper. He took the first three letters of the Greek alphabet, and his student was named Alpher, so he made that into Alpha. His name was Gamow, so he made that into Gamma. And he recruited Hans Beta just for his name. Hans Beta didn't make a single contribution to the paper, just so that it could be Alpha, Beta, Gamma.
I
And it was
see.
published on April Fool's Day. Now,
Oh, very good.
Hoyle, on the other hand, had a very dry sense of humor. He loved to talk about something like uh, people aging and, what sort of things they need to deal with. His daughter said that once um, his wife was having some physical problems and he was having some physical problems in his later years. And he commented like, well, I can, I have such bad teeth that even though, unlike my wife, I find it easier to pick up a sandwich. At least she can eat it, but I wouldn't be able to eat it in that case. And that's a little bit. I
Right.
mean, it's a little bit of a dark humor, making fun of the fact that they both were aging, but that
Right.
was part of his sense of humor.
Right. There is a remarkable passage in the book about 1964, the year when the Big Bang Theory really got firmed up with the the discovery of the constant radiostatic by Penzias and Wilson. Would you like to talk at some length about that? Because I mean, obviously, you know that that changed everything in favor of the Big Bang Theory.
Yes. So interestingly, as I found that in my research, Bob Wilson, who was assisting Arno Penzias, was a steady stater
Right.
before they did that experiment. But he wasn't really that interested in cosmology. He just thought steady state sounded more interesting. And he had Fred Hoyle as a professor at Caltech. He learned cosmology from Fred Hoyle, so he knew about Fred Hoyle. But then they started this project in New Jersey, in Homedale, with a radio telescope that was lent to them by Bell Labs from the Satellite Communication Division. So originally it was used for the Echo project to be able to detect phone signals going from one part of the world to the other. So at that time, it was revolutionary, satellite
Right.
phones. So they converted that to an astronomical telescope, and Penzias and Wilson wanted to use it to look for evidence of a radio halo around the Milky Way. But they wanted to first eliminate background noise. But everything they did to try to eliminate noise still turned up a hiss that they couldn't get rid of. So they first took into account the noise from New York City, which was nearby, and then they took into account the fact that there were pigeons living on the antenna, and they called the pigeon droppings white dielectric material, and they said that that could affect the results. So they cleaned up the antenna, and everything they did to try to eliminate all the noise still left a certain amount of noise, and moreover, that noise was consistent. No matter which way they turned the telescope, there was noise in all directions. And finally, they kind of gave up trying to explain it. But Penzias happened to know somebody who knew about a project that Robert Dicke, the Princeton astrophysicist, was doing to try to detect radiation from the early universe. And Dicke had just started working on the project. So Penzias called Dicke and said, "Here's what's going on. I have this hiss that I can't get rid of." And Dickie was on the phone. His students were around him. He said, oh my, oh my. And then he hung up and he said, "Boys, we've been scooped. Someone's beat us to finding this radiation." And
Oh,
he immediately knew that he had that they had found evidence for a hot beginning of the universe. Now,
I
Dickie
see.
actually believed in cycles. So he
Right.
thought that it was evidence of a previous generation of the
Oh, I see.
universe.
I see.
So he wasn't a Big Bang supporter. Ironically, he
Right.
believed in an oscillating universe, and that the universe contracts, expands, and goes through eternal cycles of life and death.
Right.
So, but it turned out that the radiation more closely matched that of a hot Big Bang in the beginning of the universe.
One of the key questions relates to the formation of elements, as you pointed out earlier. Uh, Gamow and Hoyle had very different approaches to it. Would you like to say a bit about that? Because, like I said, it is a key part of the origin of the universe. Lighter elements versus the denser elements. Why don't we do a bit about that?
So, what I say in my book, Flashes of Creation, is that Gamow came up with the beginning of the story and Hoyle came up with the end of the
Right.
story. So, if you want to explain how helium forms from hydrogen, helium is a second element that Gamow explained that the protons or hydrogen nuclei in the early universe go through a process of transformation, and they build up first to deuterium, and then to light helium, and then to regular helium. And in that process, which takes several different steps, most of the helium in the universe is built up. But they couldn't find a way of explaining how helium can get together and form elements such as carbon. So
Right.
we need a process in which three helium nuclei come together energetically and form carbon. And if you calculate the likelihood of that in the Big Bang theory, it's basically impossible at the temperatures and times we're talking about. Whereas Hoyle came up with an idea for a process which is now known as the triple alpha process, because helium nuclei are known as alpha particles. And that shows the triple alpha process shows how carbon is built up,
Right.
which explains why we're here talking
Right.
right now. Because if it weren't for
Exactly.
carbon, we wouldn't
We
be
won't
having
be
this
here.
conversation. Yeah. So
Absolutely.
so Hoyle kind of realized that and said, well, because we're here, there must be carbon. Because there's carbon, there must have been a process that created carbon, and that's the triple alpha process. And he showed that it can happen in the ultra compact, ultra hot cores of stars that are in the dying process, stars
Right.
that are compressing.
Right. That sets me up perfectly for my next one. Since they were both partially right, in fact, you call them complementary in a sense. Uh, shouldn't that suggest some compatibility between the Big Bang and steady state theories, given that the creation of elements have been explained by both in a sense?
Well, we have to be careful because the element creation idea in stars is independent of steady state. So
Okay.
Hoyle always recognized that it was a separate project, that it could accommodate, it could work in steady state or it could work in Big Bang. So
Okay.
Gamow came to believe in the that the higher elements were created in stars, and in fact, he said, "Isn't it strange that?" And he was speaking kind of metaphorically here. He said, "Isn't it strange that God used a simple process like the Big Bang to create helium, but then he ran out of ideas, and then that's when Hoyle came into the picture, and he created Hoyle, and Hoyle created this very convoluted process to produce the rest of the elements because God couldn't do it very simply."
Right. You're essentially talking Big Bang nucleosynthesis and stellar nucleosynthesis, right?
Big Bang nucleosynthesis was Gamow's, and then there's
Right. Right.
stellar nucleosynthesis, which was Hoyle's idea.
Right. To shift gears a bit, you've spoken in terms of how ancient philosophies such as Hinduism or Buddhism or even some Native American or Babylonians have this idea about cyclical nature of the universe, where you're talking in terms of creation, sustenance, and then destruction as an eternal cycle. How relevant is it, given that the Big Bang is still the predominant theory now?
Well, it's interesting because there are some alternatives, less mainstream alternatives to the Big Bang theory that involve cycles. For example, Paul Steinhardt developed a cyclical cosmology based upon the idea that our universe is in something like a sandwich in a higher
Right.
dimension. So it's called the brain world theory, that there are two hyperplanes. There's our universe, which is a one hyperplane, but there's a second hyperplane out there, and they somehow come together and then they separate, almost like you're putting together a sandwich and then you're
That's
ripping it
right.
apart.
Right.
And and that's his idea. And then when the sandwich comes together, it creates all this energy, and that creates what we call the Big Bang. But then it comes apart again and repeats the process again and again throughout eternity. And he recognized that that matches more some of the Eastern religions
Right.
rather than let's say Christianity in terms of an idea of eternal cycles. And
Right.
interestingly, so many religions, ancient religions, particularly Eastern religions, have ideas of cycles that run in the thousands or millions or even billions of years. So, in a way, those philosophers anticipated the great age of the universe.
Right, right. In the case of Hinduism, it surely does. It's pretty specifically calculated. Why do you think the idea of perpetual existence of the universe as having no beginning or end, uh, it doesn't sit well with the majority of serious scientists? Why do you think that is?
Well, I think most scientists uh, don't look at philosophical or religious ideas about the beginning of the universe. They looked at data and they look at the mathematics. And as Stephen Hawking showed in the mid 1960s, if you take Einstein's general theory of relativity and you imagine a dynamic universe and you trace it backward in time, eventually you reach a point of infinite density called a singularity. And that's a bit like the center of a black hole. So Roger Penrose, who recently won the Nobel Prize, said that if you have a star that's massive enough, you compact it, it becomes a black hole, and the center of it is a singularity, which is infinitely dense.
Right,
Hawking ran that film backward in time and said, well, what if you took something like a universe, ran it backward in time, you would eventually reach something like a black hole singularity, but it would be a universal singularity. And that kind of threw a wrench into the workings of people who believed in cycles. Now,
right,
later they found other ways of explaining cycles. And in fact, Roger Penrose now believes in his own model of cycles.
right,
But at that time, everybody said, well, you can't go backward in time before the singularity, because the singularity is really has to be the beginning point,
right.
because nothing because time itself must begin there, because nothing uh, there's no mathematical way of running the clock backward from that point in time.
Right, right. Would you care to speculate on what if steady state had become the deciding theory? How do you think that might have changed or impacted the laws of physics as we understand it now?
Well, I think we would have tried to understand, if steady state was the leading theory, more about what factors in the universe are perpetual, that persist over time. And that was part of the motivation for, especially for Bondi and Gold, and to some extent for Hoyle, was to try to understand where all the theoretical constants come from in the universe. Like, why is the gravitational constant of a certain strength? Why is the electrical constant of a different strength? And I think you could, if you have something that's perpetual and doesn't change over time, it's a little bit easier to say, okay, well, this equation or this theory explains why everything is the way it is. Whereas if you have a Big Bang, you have more of a dynamic origin of everything, and then you have to explain why things developed into what they are. Rather, so instead of saying these constants always existed, and the reason is because time is infinite and everything always is and was and will be the same way. With the Big Bang, you have to create more of a dynamic theory, which can sometimes be tricky.
Right, right. On a separate note, you seem to have Not a problem, but you don't seem to agree with Hoyle's hypothesis of panspermia, which suggests that life on Earth came from colliding comets. In a sense, it was planted, that's what the suggestion is. Why do you find that problematic?
Well, I'm a strong believer in evolution, and I think evolution, Darwinian evolution, has held up remarkably, and it can happen remarkably quickly, as we see with
Right,
this pandemic, that within short amount of time, um, microbes and viruses and other simple organisms have all this selection pressure. And once you have natural selection pressure, it's very easy for them to evolve because basically, as Darwin said, there's survival of the fittest,
right.
and that anything that's not fit dies out. And that is a remarkable theory, and that explains how things can evolve very, very quickly. Whereas Hoyle said at some point in his life that the chances of life evolving on Earth are practically nil. And I think it's because of his misconception. He didn't really think about natural selection or take it very seriously. He thought of it as random processes. If
I
you
see.
say, what's the random chance that a whole bunch of carbon and hydrogen atoms would randomly evolve into human beings without the selection pressure, it is zero essentially, because over billions of years, because you would have to have things randomly forming this very, very complex genetic code. But if you say, okay, you have some simple genetics and then there's a mutation or some kind of mixing, and that creates something that's a little bit better, and then there's mixing and that creates something that's a little bit better. And if you imagine running that forward in time, that naturally explains that how life evolved here. Now, could there be life elsewhere in the universe? Very likely, yes. So I believe that there's probably life elsewhere in the universe. Could it travel via interstellar objects to Earth? Well, I don't know if living things could survive. Things survive in very extreme
Right.
circumstances on Earth, but living on a rock essentially and traveling through a vacuum for millions of years, because these objects take millions of years to travel. They can't travel at the speed of light. They travel much, much, much slower.
Right.
So imagine, I mean, we could take a virus on Earth and we expose it to some radiation, or we expose it to some kind of sanitizer, and it dies. Well,
Right.
imagine what it would be exposed to for millions of years in deep space. It would be kind of incredible if it could survive
Right.
for that long. It's not impossible, but it would be incredible.
Right. One of my personal fascinations has been the role that gravity plays. For instance, I mean, I could be completely wrong, but everything that has happened on this planet is a direct consequence of the intensity of the way gravity is here. The evolution on Mars, for instance, would be very different, where it is a third of gravity of Earth. It's very different on Venus. Similarly, across the universe, gravity changes so dramatically, and it should have some extraordinary impact on even life forms. I think Professor Hoyle referred to that, right? If I'm not mistaken.
Well, I know he was Hoyle was very interested in the idea of how life would form in other places, and he wrote just not just science, but lots of science fiction stories about that.
Right,
So in the Black Cloud, he speculated about forms of life, and in his television series A for Andromeda, he imagines reproducing an alien creature on Earth,
right,
and uh, and so he was fascinated by the idea of life on other planets. And yes, gravity would play a major role if we imagine life on a low gravity planet. Um, People and other beings could be a lot taller and still be very stable. So that's why some of the early fanciful depictions of beings on Mars imagine them as being very tall.
Right, right,
Um, so we can speculate about those things.
right, right. Just last two questions. One is, what was your trigger point to look at Gamow and Hoyle? It's a subject that may not have struck a lot of people that easily.
Well, I've been a fan of Gamow since childhood,
I see.
uh, and to some extent Hoyle also. So when I was a child, I read a book by Gamow, uh, One, Two, Three, Infinity, which was a book about the wonders of science. And interestingly, Gamow illustrated the book with his own cartoons. So he was an expert cartoonist, and I
Right,
think both Gamow and Hoyle were people who were multi-talented. So they weren't just writers, they weren't just scientists. They loved to dabble in the arts. Gamow with his cartoons, and Hoyle actually wrote two operas, libretti for two
right,
operas, and TV series, screenplays. And I personally admire people who are creative in a multitude of ways.
right.
My philosophy is life is short. Why not pursue all one's gifts? And even if something is a little bit difficult, uh, it's good to push oneself and try all these different avenues. So I'm personally interested in scientists who reach out to the arts, reach out to writing, and do a lot of different things. And then Hoyle was a mountain climber.
Hmm.
Gamow loved to ride around Europe in a motorcycle and loved hiking. And I just find this very thrilling to read about things like that rather than to talk about scientists who just did calculations all the time.
Right, right,
And I think the readers would find that fascinating to read about the multi dimensions of
right.
both of those thinkers.
To conclude, you had a book on Schrodinger Einstein, right?
Yes.
This is Gamow and Hoyle. What's next?
Well, so I've done three books of pairings.
Right,
So I had, yeah, Einstein and Schrodinger. I had I had Wheeler and Feynman.
right. I forgot that one.
Yeah, but and then Gamow and Hoyle. I'm not sure when my next pairing would be. Maybe look at all different uh, look at different possibilities in history of conflicts. But I do like the idea of juxtaposition
Right.
of ideas. So currently, I'm working on some articles.
Mhm.
Sometimes I write books, sometimes I write articles, and I'm writing one about the principle by Ernest Mach. Uh, this idea of that inertia comes from the stars. So I've been invited to write a paper on that. I've been invited to write a paper on the history of experimental general relativity and the connection with John Wheeler. So I like to keep active and do a variety of things and dabble in different areas. So, well, it's wonderful being on your show, and
Oh,
I see you interviewed John Bolton recently.
I mean, I'm a journalist by trade, so I interview any interesting figure.
Okay.
He happened to be available, so
Yes. Well, I appreciate, as I said in my email, that you're interested in so many areas, art and
thank you. Yeah, thank you.
writing, and
Right.
that's great. And you know, it's it's inspiring for me to look out at Renaissance people who explore all
Oh, how nice of you to say
different
that.
areas.
Right.
So,
And
and I think I found that with Gamow and Hoyle too, that they were
yeah,
willing to.
one chooses to be eclectic, so.
Yes, yeah, that's right.
I'm sorry I'm dragging it a bit, but since you mentioned, is there any possibility of steady state making a comeback in some fashion?
Well, I think if Hoyle was clever, I mean, he was clever,
Yeah,
but he could have said that the multiverse, as you alluded to,
right.
um, was the grandchild or child or grandchild of steady state. Because
Wonderful, yeah.
he could have just said, well, instead of one big bang, there's multiple big bangs, and the universe lasts forever, and the steady state is the creation and destruction of big bangs.
Right. Oh, there you go. That's fascinating. This is
Yeah,
it. I'm glad you said that. Thank you very much, and it was an absolute pleasure to meet you.
it's a pleasure meeting you too. Bye bye.
Likewise. Bye bye.